I'm Anil Kumar. Welcome to my series on polar coordinate system. In this video, we'll discuss about polar coordinate system. We'll represent polar coordinates on polar grid. We'll represent negative radial coordinates. We'll also talk about uniqueness of polar coordinates. We'll do conversion from Cartesian to polar and vice versa. We'll discuss with an example which could be explore these points on Cartesian as well as on the polar coordinate systems, right? So what is polar coordinate system? So a few things which you should remember here is that polar coordinate system is a two-dimensional coordinate system, right? So it is two-dimensional coordinate system. Now, in this system, we represent every point with reference to a point, which is called reference point, and with reference to a direction, which is this direction, right? So, this particular point which I have drawn here is called the pole. And the line is the polar axis. This line here is called the polar axis. So, polar coordinate system basically is a two-dimensional system, and we represent each point with distance from this reference point and an angle from the polar axis. So normally we'll represent this in the form of r and theta, where r is the distance from pole, right, and theta is angle from polar axis. Now, as far as theta is concerned, it is positive when measured counterclockwise, right? Now, let me give you an example. Let us say if I have a point P whose coordinates are, let's say, 2 and 60 degrees, it basically means that we are talking about a point which is 2 units away from the pole, and it is at 60 degrees with the polar axis, right? So you can go 60 degrees from here. For example, that becomes 60 degrees. And if we have, let us say, this as 1 unit, in that case 2 will be twice that length. So that point P, whose length is 2 from pole, which we normally put O for pole, right? So just as we have origin, we can have a reference point O, and this distance is going to be 2, right? So that is how we represent 2 60 degrees on this particular plane. So as you can see here, when you compare it with the coordinate systems you are aware of, Cartesian coordinate, we have two axes, x and y. Here we have a line L, right? And this particular line, which is called the polar axis, gives you the reference of the point in terms of the angle. And the pole itself gives you the distance of the point from the pole, that reference point. And that is how you represent your point on this particular polar coordinate system. Now, normally we'll write P in terms of r and theta. We could also use the symbols for point as rho and phi. In fact, the SI units is phi for representing the angle. So most of the time, we could also write phi here to show the angle, and this angle is positive when it is clockwise. Perfect. So that is how it is. So if you have a point which is, let us say, if you have a point which is P1 and the angle is 120 degrees, in that case, the angle will be 120 degrees, kind of like there, and the distance from this point O will be 1 unit, right? So let us say this much. So this point will be P1, 120 degrees. You get an idea, right? So let's say this is some other point, P dash. So that is how you can plot. So you can plot any point on this plane by knowing the distance from the pole and the angle from the reference line, which is called the polar axis. So this reference line, we take it horizontal, just as in Cartesian plane, we take x-axis, right? So you can align it with that and think about it to be positive moving right, correct? So that is one of the major things about the polar systems. Now sometimes the question is, we are saying 2 is the distance, right? So distance cannot be negative. How do you represent negative numbers? Well, we could represent minus 2, 60 degrees as a point which is on the opposite side of this line, right? So OP, and if I draw like this, then that point Q, let us say, can be considered as minus 260 degrees. So as far as the R value is concerned, if R is greater than 0, that is to say if R is positive, then it is in the same direction as the point, right? So then in that case, it is in the same direction as the angle, I should say, right? In this case, angle is 60 degrees. However, if R is less than 0, in that case, it is in the opposite direction. So in case you have to represent a negative number, in that case, you could first plot with positive R, get the location, and then go in the reverse direction, right? So what you notice here is that it is a movement of, it is 180 degrees turn, right? So that is how you get negative numbers. Well, you could also represent negative angles, right? So the angle could be, if I have a point which is, let us say, let me draw a point, something here. Let's say we have this, right? And this position here, let's call this as N. So this point N here happens to be, let us say, 50 degrees, but clockwise. So it will be negative 50, perfect. And let us say it is 1.2 units. So it could be 1.2 units and negative 50 degrees. Correct. So that is how we could also represent negative angles. So negative means it is going in clockwise direction from the reference polar axis. Is that clear to you? So I hope you understand how we could actually represent any point on a coordinate system, polar coordinate system, right? Now these angles could be in radians or could be in degrees, right? So that means I could also say that this point is 2 and pi by 3, correct? So both is same thing, perfect. So you could write the angles in radians or in degrees. So I hope that point is absolutely clear. Now let's see what are the ways of drawing points on a polar graph. Polar graph or the polar grid, you must have seen, is concentric circles with the pole and the polar axis. So this is your polar axis. Now here, the diagram which I have picked up, every portion has been divided into 30, 69, 30 degrees, right? So let me write this as 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees. So going counterclockwise, it is positive, right? 210 degrees, 240 degrees, 270 degrees, right? And then 330 degrees. Sorry. So 300 degrees, 330 degrees, and 360 degrees, right? Also 0 degrees, right? So that is one full circle. We could also label this in radians, right? So if you have this as 0, then the radians will be, each has been divided into pi by 6 divisions we have here. So pi by 6, 2 pi by 6 is pi by 3, right? This is pi by 2. Now this could be written as 1 pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, correct? 4 pi by 3, 5 pi by 3, 6. This is just, we can write pi here, right? We can write this as 7 pi by 6. We could write this as 7 pi by 6 also, right? 7 pi by 6. 8 pi by 6 is like 1 pi by 3, 2 pi by 3. Sorry, this was 2 pi by 3. So 3, 1, 2, 3, 4, 5 pi by 6, that is wrong. Okay, 6 pi by 6, 7 pi by 6, 8 pi by 6 is like 4 pi by 3. Is it okay? Right. So we have 1 pi by 2, 2 pi by 2. This becomes 3 pi by 2, correct? 3 pi by 2. So now getting back to pi by 6, we have 6, 7, 8, 9, 10. So when we have 10 pi by 6, then 10 becomes 5 pi by 3, right? So we just simplify that. And this is 11 pi by 6, and that is 2 pi. So we could label this in degrees or in radians, right? So as an exercise, what you could try is, we can try some angles and some polar coordinates to plot on this. So let me take point A, which is, let us say, now each circle, will take this as one unit, right? So this is 1, 2, 3, 4, and 5. So if I have a point A, which is 30, and let us say it is 210 degrees, correct? Then A point, which is distance 3 away, and along this direction of 210. So it would be 1, 2, 3 units. So that will be the point, right? So that becomes your point. Here, as you can see, the pole is right there, and the reference is this axis, which is the polar axis, correct? So that becomes your point A, right? So let's say we have a point B, which is, let's say, minus 2, and let's call this as 120 degrees, right? So when I have to plot minus 2, 120 degrees, we'll look into the angle of 120 degrees, go 2 units, right? So that becomes the point. But since it is minus 2, so we will actually draw it on this side. So that becomes B, which is minus 2, 120 degrees. Do you get the idea, right? So that is how we have to place a point with a negative distance from the pole. You get the idea, right? So that is the idea. Now this is called the radial coordinate, and that is the angular coordinate, right? Now, so likewise, you could practice, and for you can plot a point C, for example, as, let's say, 4 minus, let's say, 120 degrees, right? So you could practice this. Remember, negative means you have to move in the clockwise direction. So 4 units and 120. So that means this is 90 and 30. So that becomes 120 from here, correct? And the distance is 4. 1, 2, 3, 4. So that becomes your point C. Is that clear to you? So that is how you could get the location of these points on the polar grid, right? So this polar grid could be divided into many angles, right, as per your requirement. Perfect. So if I have, let us say, D, which is, let us say, 45 degrees, right? So let's say D is, let us say, 1 unit, but 45 degrees. So we didn't mention 45 here. 45 will be in between these two, 1 unit away. So between these two, we could plot this at this point, will become D for us. Does make sense to you, right? So accordingly, you can actually plot the points as you are seeing here, right? Now let us practice with some points in radians. So in radians, let's say we have a point here, which is 3 pi by 6. So when I say 3 pi by 6, then you go 3 units away, right? 1, 2, 3 from the pole, so that's the distance, and travel the distance pi by 6 angular from the reference line, which is polar axis, correct? So that becomes your point. Let me call this as A dash, right? So that becomes with radians, correct? So now let's have B dash here, and B dash, let us say the angle is 3, okay, let's put 3, 5 pi by 4, right? So when I say 5 pi by 4, then it is 1 pi by 4 is here, 2 pi by 4, 3 pi by 4, 4 pi by 4, and 5 pi by 4 will be somewhere here. And 3 is 1, 2, 3, right? So that will be your point B. Is that clear to you? Perfect. So any angle with negative will be clockwise, and if the radial coordinate is negative, then we have to go to the opposite side. So let me take C dash here, some other C dash. Let's say we have 3, and let's give this angle as 7 pi by 6. Well, we want to make this 3 as negative 3, right? So basically, you'll go 7 pi by 6, which is right there, but your R is located in the opposite direction. So we'll actually travel in this direction 3 units. And we come here, right? So this point A dash is also the point C dash, right? Now from here, by chance, we also discovered that any point on the polar axis could be defined in many different ways, right? So that means it is not unique, right? It could be defined in many, many different ways. Perfect, as you've seen here, correct? So that is very important to understand. Now here is a practice for you. We'll now work more on negative values of radial coordinates, right? So let's say if I have to plot minus 3 pi by, let's say, pi by 3, how will I do it, right? So on this graph, pi by 3, this is pi by 6, that is pi by 3 units. So basically we are going in this direction, which is pi by 3 here, right? Minus 3 means we have to go in the opposite direction, 1, 2, 3. So that becomes your point. Do you see that? So this is the point, let's say this point. Point R will be shown here, right? Does it make sense to you? Now you can write down some more points and then plot them. So it's good to practice at the moment. Now let's look into some other point. Let's say point Q. We'll take this in degrees, and let's say we have minus 4 and minus 120 degrees. Now when I say minus 120 degrees, so we'll go in this direction, correct? So 90 plus 30 is minus 120 degrees, so we are in this direction. However, 4 is minus, so we'll go 1, 2, 3, 4. So the point will be right there, and that will be the point Q. You get the idea, right? So that is how we are going to get our points on the polar grid, right? So you could actually copy these diagrams and practice placing them on the polar grid. Now we'll actually work a bit more on uniqueness of polar coordinates. What you just learned is that there are many ways of referring to a point. So let's get back to this. We have a pole here, and this is our polar axis, correct? So a particular point, let's say, is at angle phi, and let's say it is r distance away, right? So that is our point which we are saying r phi. So this is a point which is given to us. Now I can write this point, let's call this point P, which is shown here as r phi, in many different ways. One, I could always go full circle, right, and come back to this, correct? So we could do that. We can go one full circle and get back to this, right? That means I could also write this point P as r phi plus, now any number of circles we can go to, right? So phi plus 360 degrees, right? Or n times 360 degrees. If you're working in radians, it'll be 2 pi n, right? So let's say in radians, it'll be P will be r phi plus 2 pi n. Is it clear, right? So either way, it's one and the same thing. So that way is where n belongs to integers, right? So we could have infinite points here. You also notice one thing, that this could be represented even by going in this direction, right? So you see, or by negative r. So now let's look into a point which is kind of here. Okay, so what I could also write this as, point as, now this is negative r of an angle which is 180 degrees moved, right? 180 degrees moved. So let us talk about another point which is negative r phi. So we are calling this P dash. So P dash is negative r phi. It's a new point, right? It's not that point. It's a different point. So negative r phi, if you look into this, in that case, we will write this as equivalent to what? Negative r what else? Now in this case, you will notice that we have to get back to this point. That means we have to add 180 degrees or pi, right? And then 2n pi. Do you see that? So it becomes whatever the angle phi was plus 180 degrees plus n times 360 degrees. Do you understand? So that becomes the combination. So when r is negative, I can write this point as taking 180 common, phi plus taking 180 common, we get 1 plus 2n, right? 1 plus 2n. Do you see that? So a coordinate with the negative 1, you could have many combinations, but that is going to be the angle, correct? So if it is positive, just do 360n or 2 pi n. But if in this case it is negative r, then think like this. You have to get back to this position and then 360n, right? So r is negative, right? So you have to get back to the original position and then 360, right? So that is how we'll have to place these angles. Now, we'll also learn that how to find angle soon. And what hint I want to give you is tan inverse, let us say tan inverse of, let's put x at present, is defined from minus 90 degrees to plus 90 degrees, correct? So at times, we also write our angles from minus 90 to plus 90 degrees. Since using calculator, you get tan inverse from 90 degrees to minus 90, that is the range, right? So what I'm trying to say here is that the angle phi, what I'm saying here is that angle phi is between 0 degrees and 360 degrees, right? What we also do is we also place phi from minus 90 degrees to 90 degrees, right? So we may, and then adjust with r, make r positive or negative to refer to the points in quadrant 3 and in quadrant 4. You get the idea, right? So this can be used to write r with negative values as minus 90 to 40 will give you points in quadrant 1 and 4. However, with negative r, we can also cover points in quadrant 3 and 2, right? So this will be required only when we look into Cartesian coordinates next. Conversion. So in that case, we'll look into this point, okay? Now the next point here is what I was talking about. Let us see how Cartesian coordinates and the polar coordinates are related. This is very important, since most of the time we are very familiar with the Cartesian plane, right? So we are always saying a point is represented here, and let's say the value of the point is x coordinate is x, y coordinate is y. So that is the point given to us. Now if I say equivalent position on polar coordinates, right? So let us say on polar coordinates we again have the same position, right? So that's our line, and we are saying that this point here is kind of here, right? So we need to find what is this value of r and what is this angle phi. So once we know that, we can define the point P as r phi. Is that clear to you? So that is on the polar coordinate system. So how do we find r and how do we find phi? So let's recall some trigonometry which we have done. So if this angle here, we'll call this phi for the time being, right? In that case, from O, let's say this is n, then O to n is x cos phi, right? This is x, if this is r, then x is equals to, let me write down here, x is equals to r cos phi, correct? And the value of y is equals to r sin phi, correct? So this is r sin phi, and this is r cos phi. And from here, if we add their squares, x square plus y square will be equals to r square cos square phi plus sin square phi, and this is 1, and therefore we get x square plus y square equals to r square, and that gives you the value of r as square root of x square plus y square. So that is how you could relate from your Cartesian to polar, right? Now, as far as the angle phi is concerned, we know tan phi, you can say tan phi is equals to y over x, correct? So angle phi is tan inverse of y over x, correct? Now what I was talking about is that if you use your calculator, then the value of phi will only be defined in these two quadrants, right? So this value will be from minus 90 degrees or minus pi by 2 to plus 90 degrees, right? So that is what it is. I should write equal to, since tan value will be undefined, correct? So that is a problem. So we don't normally write equal to, since tan 90 will be undefined. Okay. Now the idea here is, how do we represent a point which is on this side? So if the point is on this side, for example, if I take a point here which is minus 1 and let's say plus 1. If that is my point, then the tan phi value will be calculated by the calculator will be negative 45 degrees, right? So it will be negative 45 degrees. Then you can take help of negative r to give this value. So that is what we are getting to. In the rectangular plane, we have x and y, and any point which is represented here has a value which is x and y, right? So that is the value. So let's say we have a point here. In the polar form, we're actually finding or locating a point with two things. One is the length and the other thing is the angle. Now this axis which we have along the x-axis, this is our reference axis along which our pole moves, right? With the center here at the origin, right? This is the pole. Now a point rotates in counterclockwise direction, then we consider the angle to be positive theta. So if I have a point which is right there, correct? In that case, the length of this determines the magnitude and the direction theta locates the point in the plane, correct? So the point could be written as r theta, where r is this magnitude. Now if you try to relate these two, in that case what we observe here is that this length can be represented with x and y. So that is the x, this is y, and equivalent r, the magnitude, which we call here modulus. So this value r, using Pythagorean theorem, can be written as r square equals to x square plus y square, or r is square root of x square plus y square. So that is how we can get r from x and y values, and so we get this part. As far as theta is concerned, so this is the angle which we are talking about. Theta is called argument. Now to find this, we use tan ratio. So we can say tan theta is y over x. So theta is tan inverse of y over x. Normally these angles are given radians, but you can use degrees also. Now this part is kind of tricky here. There are two things which we have to take care of. One, r could be negative. So if r is greater than 0, if it is positive, then r is in the same direction as the line joining this, right? So if the point is here, for example, in that case, r theta will be represented like this. However, if r is less than 0, then it acts in the opposite direction. So for the same position r theta, we could have this position where the value will be minus r theta. You understand? So if r is negative, it acts in the opposite direction. So that is how we can also take care of values of r which are negative, right? So do you understand this part? So this is kind of important to understand. Another thing which is very important is to realize that in the polar system, we could have many values of theta. So the theta is normally equal to theta plus 2n pi. After every circle, we come to the same position. So theta becomes same as theta plus 2n pi. Now if I are looking into the negative r portion, this is when r is greater than 0. However, when we are looking into the negative r position, if I have negative r theta, in that case it is 2n minus 1 times pi. Okay, because then you are moving in this direction, correct? So it is 2n minus 1 pi. So these are equivalent values, right? So r theta could also be written as minus r theta 2n minus 1 pi, and this is same as r theta, where this theta basically is equal to 2n, I should write in this case plus 2n pi, right? That's what it is. So in case it is negative r, in that case it is theta plus 2n minus 1 pi, correct? So that is very important to remember. So that means for any particular position, we could have infinite values of theta, right? Now with this in mind, let us answer the questions one by one. The very first question is based on this concept itself, that you could define a polar coordinate in many different ways. So the question number 1 here is, find the polar coordinate which will not match the rectangular coordinate 1 square root 3. So when you say 1 square root 3, it means what? Well, let's try to visualize. So it is kind of like this, 1 square root 3, that is the position we're talking about. So the y value is square root 3, and this is 1. So the angle is how much? From the special triangles, you know this angle has to be 60 degrees. Right? So theta could be 60 degrees. Second, the value of r will be equal to square root of 1 square plus square root 3 square, right? Which means it is 1 plus 3, which is 2. So the magnitude of 2 is correct. And one of the values which is equivalent is definitely 260, correct? In degrees. So this is perfectly fine. Now the next value here is minus 2, 240. Now what does that mean? Now when we are talking about minus 2, that means we are talking about the value being here, right? So that the same point can be written as minus 2. Now if it is minus 2, 240, then this angle is 240, correct? So 240, and if we do minus of that, then we are looking into this point. So it is minus 2, 240. Do you understand? If we look into the opposite direction, then it is minus. So this is also correct. You get the idea, right? So this is kind of tricky to understand. Next is 2 minus 420. Now when we are looking into minus 420, that means we have to move like this. Now 360 is one full circle, right? 360 is one full circle. And then it is 60 more. So 60 more means we are in this coordinate. So definitely this does not match. Correct? So this is the one. It does not match the given coordinate. Minus 2, 960. Now let's look into this. 960 means what? When we say 960, well, let's take away 720, right? Two circles. And so we get 240, right? So it is same as B, so it works, right? Minus 2, 240. So that works. So now I hope you understand when I said that minus r, we have to look into theta plus 2n minus 1 times pi, right? So that is important. So these angles are equivalent to r theta, right? And also equivalent to r theta plus 2n pi. Is it clear to you? So all these angles are equivalent angles, as you can see in the very first example. Perfect. Now let's move on and take the second question. Match the point P minus 1, 1 in the rectangular coordinate to one pair of polar coordinate. So let's find r first, right? So r will be square root of 1 plus 1, which is square root of 2. Now square root of 2 means it could be one of these three. Second is about the angle. Okay, so let's look into the positioning We are saying minus 1, 1. That means the point is here, right? Minus 1, 1. So you are in quadrant 2 now. So in this quadrant, what is the theta, the argument? 45 degrees, right? So it is 135 degrees. So it is square root 2, 135 degrees, but this is 1, so it is not correct. Then we have square root 2, 45 degrees. That is also not correct. Minus of 2, 225, that is not correct. 225 will be here. But minus square root 2, 315, which is here, that is correct. So option D is the correct option. Do you understand? So this positioning, minus 2, 315. So 315 will bring you here, but minus 2 will get you back to the point which we are referring to. So D is the correct option. Is that clear to you? Right? So that's kind of important to understand. So let's move on and see question number 3 and question number 4. Question number 3. Find the rectangular coordinate which will match the polar coordinate minus 13, minus 67.4 degrees. Now let's try to sketch this to understand. So we are talking about the angle which is minus 67. So let's say we move here minus 67, and we are not going into this direction. Since this is negative, we are actually going here. So we are talking about this angle. That is the point P. Do you understand? So minus 67.4 degrees. Since the R value is negative, we are not going here. We are going to that place. So that is the point of reference P. Now for this point, we need to find what is the correct value. So magnitude, which is R, is given to us as minus 13, right? So minus means go to the opposite direction, right? Now when the gradient, the angle is 67.4, then we have to see what is the value. Is it tan of 12 over 5 or 5 over 12, right? So let's figure this out. So let's figure this out. What is tan of 12 over 5 equals to, right? And what is tan of 5 over 12? So that is very important. So tan 12 divided by 5 is equal to, we'll see what is tan of 67.4, right? So we'll say tan of 67.4 equals to how much? So it is 2.4, we say tan of 67.4 is equals to 2.4, right? So we have taken positive value. Now when it is more, that means we are looking into the triangle where the greater side is here, right? So that is the angle 5. So x and y values are 5 and 12. Do you understand? So that means we are looking for 5 and 12 in this quadrant. So this is definitely minus 5 and that is 12, correct? So that is how we are locating it. So we have this option which is minus 5 and 12, which matches. You get the idea, right? So that is how we are going to locate the points. So I hope the steps are clear. Question 4. Find the rectangular coordinate which will match the polar coordinate minus 5, 36.9, right? So you can actually pause the video now and answer this particular question. So when we are saying magnitude R is 5, then we're definitely saying this is like square root of 3 square plus 4 square square root, right? Which is 5, correct? So again, the combination could be 3, 4 or 4, 3, right? So we have to now figure out whether it is less than or greater than. The idea is that if tan of 45 is considered as 1, right? We know tan 45 degrees is equal to 1. Now, since this is less than 45, we are talking about position being here, right? That is 36.9, which is less than 45. So definitely The point here is 4 and 3, right? So we have a combination of 4 and 3 since this is less, right? So now we are saying that this minus 5 means the point lies here. Do you see that part? That means both should be negative, right? And the y value is smaller than x value. X is more. So the correct option here is C. Minus 4 minus 3. Does make sense to you? That is how we are going to locate. So let me summarize that. Important thing is that tan of 45 is 1. So if we have an acute angle alpha as greater than 45 degrees, then tan of theta will be greater than 1, right? But if acute angle alpha is less than 45 degrees, in that case, tan of alpha is going to be less than 1, right? So you should say tan of alpha. Is that clear to you? So that helps you decide whether it will be 3, 4 or 4, 3. Perfect. So I hope that helps. So that is kind of a basic rule which you should keep in mind for answering such questions. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.